So step 5 of the process is Kaizen. And Kaizen is continuous improvement. And it's a way to reduce costs and increase our efficiency throughout the manufacturing stage of the product lifecycle. So this is part of our production process. Different ways that we can achieve that Kaizen continuous improvement are by streamlining our supply chain, using lean manufacturing, improving our manufacturing methods, productivity programs, changing our factory layout to reduce our manufacturing cycle time, using different management techniques. We might move from a normal manufacturing production to a cell production or just in time production. And we're mostly looking at the time period between product redesign. So remember, Kaizen focuses specifically on the manufacturing production part of the life cycle. Now we're going to look at a target costing example. We have a company that manufactures a hearing aid. Our product has 30% of the current market. It has a cost of $650 and sells for $750. A competitor has just introduced a new model that incorporates a computer chip that improves quality. Its cost is $1,200. A consumer analysis indicates that consumers will remain loyal to us as long as the price does not exceed $600. We want to maintain our profit of $100 per hearing aid. Therefore, we need to reduce our cost to $500 to meet our profit goal. So the new market price is $600, our desired profit is $100, and our new target cost is $500. So we're going to look at this product and see where we can cut $150 from the cost of production. So we have a couple of different options here. In alternative A, we're going to reduce research and design, replace parts, and change our inspection procedure. In alternative B, we're just going to replace parts and change inspection procedure. And in alternative C, we're going to increase our research and development to develop a competitor to that computer chip hearing aid. And then we're going to replace parts, change the inspection procedure, and negotiate a new supplier contract. So when we look at the different examples, we see that management chooses alternative C because that increase in research development is going to improve our competitive position in the future. This is important because we already have a competitor on the market with this new technology. So in order to even maintain our competitive advantage with loyal customers, we also need to look at getting a hearing aid with the computer technology out on the market like our competitors have. We also have quality functional deployment. So QFD is the integration of value engineering that we discussed earlier in the chapter, marketing analysis, and target costing. So we bring all of those together to determine which components of the product should be targeted for redesign or cost reduction. So as part of the value engineering process, we go out and ask customers criteria for the product. So what are those things? First, we would survey, do a market analysis of our customers. Then we would come back and see how we can remove different products without affecting customer satisfaction. So in this example, we have ratings of safety, performance, and economy. So the example that this is our customers were asked to use a scale of 1 to 100 to rate the importance of each of these options for a saw purchase. So they're going to purchase a saw, and safety has a 95 importance, performance 60, and economy 50. So we add up those rankings and get the percentage of their relative importance. Then we look at the cost of each of the components of a saw. We have a motor, the saw, and the frame that's holding the saw. So our total cost is $75. And we have the percent of total cost. Then we want to look at how those components contribute to customer satisfaction. So the safety, performance, and economy, which was the customer criteria, versus the component parts. When we do that analysis, we find out that the frame has a higher weight on our importance index than the saw and the motor for the saw. This means that the first place we would look to save money is in the motor. So we showed that too much is being spent on the motor component relative to its value to the customer, and not enough is being spent on the frame relative to its value to the customer. So in our redesign, we would look to build a higher quality frame, but find a lower cost motor. The benefits of target costing are that our design is focused on customer value. So there's the potential for increased customer satisfaction. If we're looking at designing products that make our customers happy, then our customers are more likely to buy them and then be satisfied that they have them. We're looking for more effective and efficient design. So we're not just looking to cut costs, we're looking to strategically reduce costs by being more efficient in our labor, more efficient with our direct materials, and having a lower cost design. We're looking at desired profitability on new and redesigned products. So it allows us to strategically think about that. It decreases the total time for product development because we're coordinating design, production, and marketing into one full thing. So our design team is working with marketing and production to make sure that what they're designing is already efficient and meets customer requirements. We have increased cooperation and communication among departments and overall improved product quality. One of the ways that we measure production speed is through manufacturing cycle time. So manufacturing cycle time is the amount of time between the receipt of the customer order and the shipment of that order. So the start and finish time can be defined in multiple ways. We have an example where the start time could be defined as the time the raw materials are ordered, and the finish time is the time production is complete. So instead of shipment when production is complete, or instead of when a customer order is received when the raw materials are ordered for that order. So our manufacturing cycle efficiency is the processing time divided by total cycle time. So this separates our total cycle time into processing time, inspection time, materials handling time, waiting time, and so on. We want to try to get our manufacturing cycle efficiency as close to 1 as possible. What another way to look at that manufacturing cycle efficiency is that that processing time is anything that's considered value added. And the total cycle time also includes non-value added activities. So these activities that slow a product's total cycle time are called constraints. In our theory of constraints, we look at what are constraints to production and how can we help maximize the flow through that constraint. So do we have bottlenecks at different points? That's a constraint. And how do we move past that constraint as part of the manufacturing process? Can we add capacity? And if we can't add capacity, do we have to redesign the manufacturing process to increase our cycle time? So we have an example. We have 2 hearing aids now. We've made the new hearing aid with the computer chip. Our prices are competitive at $600 and $1,200. They're not expected to change. Our monthly orders average 3,000 units for the first one and 1,800 for the second one. New customers are told they have to wait at least 3 weeks for their orders, and management is concerned about the need to improve speed in the manufacturing process. So customers don't want to wait 3 weeks for their orders. We all know that when we order something, we want it now. Nobody likes to wait for things. So we don't want to have that 3-week delay between the time an order is placed and when that order is received. So we're going to try to identify what is causing some of the delay. So the first thing is we would look for what is our constraint by developing a flow diagram which shows the sequence and time of all of our processes. So we have the direct materials, assembly, installation, finally assembly and testing, and then packaging and shipping. So we use the flow diagram and additional operational data to look for the constraint. So we have there's difficulty maintaining adequate staffing in all processes areas except process 5. Our analysis of the process flow, staffing levels, and process time shows us that the constraint occurs in process 4, which is final assembly and testing. The other 4 processes have slack time, which means that they have time that things could be moved slower or faster, but process 4 is our holdup. So here we have the final assembly and test is where our constraint is happening. Then we want to look at the most profitable product mix given our constraint. So we have the HP12 and the HP13. So we're going to look at the throughput margin to determine the most profitable product given the constraint. So the throughput margin is the selling price less materials cost. In this example, the relevant measure of profitability is the throughput margin per minute in final assembly and testing. So because that is our constraint. So we look at this example. Our throughput margin, which is price minus materials, is 300 for the HP12 and 450 for the HP13. That is our throughput margin. Our constraint time is the time for process 3 or 4. So it takes 30 minutes for the HP12 and 60 minutes for the HP13. So our throughput per minute is $10 for HP12 and $7.50 for HP13. So the HP12 is the more profitable product per constraint time minute. So this is similar to looking at the contribution margin per constraint that we did in a previous chapter. So we're going to produce all 3,000 units for HP12 because it's the more profitable, and any remaining capacity is going to be used to make HP13. Therefore, we reduce the cycle time on those units by utilizing the highest margin per that constraint. We want to maximize the flow through the constraint. So we're going to look for ways to speed the flow by either simplifying the process, improving product design, reducing the setup, reducing other delays, or adding capacity. So we saw in the other information that we had problems staffing this area. So if we could properly staff it, we might not have the capacity issue or the constraint to begin with. We want to balance the flow of production so that really no one is waiting for other things to be finished. We don't, waiting time is non-value added time. So our desire is to remove non-value added activities and improve the value added activities.